Okay. Thank you so much. Thank you, everyone. Thank you again for today. Thank you for joining us. Um, if you are connected, say connected. If you are connected, say connected. Type connected in the chat box. If you are connected, type connected in the chat box. If you are connected, type connected in the chat box. So I know those who are available, who are watching today. So type connected if you are connected. All right. Thanks so much again for joining again today. Thanks so much for joining again today. Without much ado, I think we will go into today's class. And in today's class, we'll be talking about Springboot. We'll be talking about Springboot. Last week, in our day 20, we tried to review what the Springboot is. So I'm going to start all over again with the Springboot. Here we are saying that Springboot is a collection of frameworks, a collection of free Spring frameworks to perform or write enterprise Java applications. Enterprise Java applications. By enterprise, we mean a client-server related applications. The client is the front end that connects to a specific back end, and then a client connect to a specific back end, and for the back end you have application that also connects to dependencies, backend dependencies, which could be an email server, which could be a file system, which could be a database, which could be a third-party system. So that's what a backend is all about. Before now, we have tried to look at Jdbc, Java Database Connectivity, where we wrote Java-based program that connects to database, and then we look at a different type of database operation we can perform for insertion, for retrieval, querying for retrieval, and then using appropriate Java database classes to handle such. For such database classes, we look at connection class. The connection class connects to the backend, makes actual connection to the database. So here we have things like connection. We dealt with statements. We dealt with prepared statements. We dealt with ResultSet. And in all these are Jdbc, that is Java connectivity, Jdbc, Java database connectivity, Java database connectivity. So with the connection, we use a connection class to connect to a backend database. We use the statement class to create query that connects to database. We use the we use the statements to create query that connects a database, and we use the prepare statement to write statement that would not be compiled, that just be compiled one time. And then we use ResultSet to map whatever thing that is retrieved from the back end to the front end. That is to fetch the columns and rows from a database. They are all in the ResultSet, and we iterated through ResultSet to get the data in the database. This could become cumbersome as we have to write classes that we need to instantiate to connect to back end, and then to connect to front end, and then to create servlets. Servlets are Java classes that generate HTML sources. Now, to get back to Springboot, Springboot contains a collection of frameworks, Spring frameworks, collection of Spring framework is Springboot. Springboot equals to collection of Spring frameworks for bootstrapping enterprise applications. Yeah, so what it does is that it contains a boilerplate to ensure that we start our web application in no time. So they are tested, their batteries and charges. They are tested classes. They are tested modules over the time, which are all bundled together. So, and that is why it is called Springboot. Spring from Spring frameworks, and then the boot is to bootstrap. That is to make it quickly for you to start something, to make it quickly for you to build an application. Now, for this framework, we have Spring frameworks. Here we have a Spring JPA. We have a Spring AOP. We have I'm going to explain those ones. We have a Spring we have mentioned, we have a Spring Web, right? So we have a Spring JPA AOP Web. Let's also see. We have a Spring template. Templates could be for Jdbc, template for JMS, and so on and so forth. So Spring. So the Springboot contains of different Spring frameworks, that is Spring applications that have been written for specific tasks. For example, Spring JPA helps to create database related application. JPA, Java persistence. So it allows for creating database related application for like CRUD operation, create, delete, update. CRUD, which is create, update, delete. In fact, create, read, update, of data in database. So for Spring JPA, we have the JPA there stands for Java Persistence, which is a library to allow us or to enable us to write applications that connect to database and to be able to perform different operations on the database, that is creating records in the database, reading records from database, deleting records from database. Then we have a string AOP aspect. There's something called aspect oriented programming. In Spring aspect oriented programming, it enables us to do After Effects, or after a process has been completed, when we want to fire an event, so the event that you fire, the event or the kind of task that you do after a transaction or a process has been completed is what aspect-oriented programming is about. For example, let's say we do a transaction, whether it's debit or credit to an account. Immediately, the account owner can receive an alert. That alert is sent after transaction has been completed. So that alert is bound to completion of a transaction. So it allows us to mark, stages or phases of a particular process. That is like on completion of a process. Before a process is completed, or before a process is started, we can also trigger an event. Or in the middle of the process, we can also trigger an event. The Spring aspect-oriented programming allows us to be able to, create such events. Then we have Spring Web, which is where we are going to focus on. Spring Web allows us to be able to create web application. That is, start up a web server. Create a web server for serving documents. This time around, serving and processing. Let's put it like that: serving and processing document. Now, in this context, if you open YouTube now and you type youtube.com, just like the current video that we are watching, you will see that on your browser you don't see a video until you have typed youtube.com. Now, so what that means is that your browser is requesting a document, and in this context, the document is a video. It's requesting it from a server. It's requesting a video from a server, and in this context, the server is YouTube. So how do we create a server that serves a content to the web? That is what Spring Web does for us. In Java, there's something that's called servlet. The servlet generates HTML. We have seen HTML before. We have worked on HTML, so HTML documents. Now, you can request for a document by typing the website and then the address to the part of the document. So that is serving documents. Then we also look at Spring templates. These Spring templates could be like Jdbc templates, JMS templates. We know what Jdbc is already. JMS means Java Messaging System or Service, Java Messaging Service. JMS, Java Messaging. Here we can pass a message, which could be a textual message or an object message around, sending it to another Java process or sending it to another system. This is what is called Java messaging services. So having said that, let's start with the basic of the whole thing to spring up a web server. Our focus today is to quickly start with a web server and then start building that web server to the point that we'll be able to serve other contents like YouTube and things like that. So to quickly serve a web server, So having said that, so we're serving a web server, and the web server is to be able to allow us to visit that web page, get the content from that web page, and then also send a request to that server, to process something for us. So those are the things that we are going to be looking at. Today. Serving a web server, starting with a web server that generates a web content, for us to work with. Okay, so having said that, let's take a quickly look at that. The first thing we need to do to start a Springboot application is that we update our build.gradule file. But before we do that, I'd like us to divide our application into 4 parts. And the 4 parts is that we have what we call configuration. We have configuration, right? I think yes, under Springboot we have configuration. So I'm going to bring this here. So we have Spring configuration, and then we have repository, we have service, we have controller. The configuration helps us to configure a backend that is maybe minimum parameters that is needed for the application to run. Repository connects to database, connects to actual database. And then we have service. The service contains business logic. What do we mean by business logic? Is the code that perform the actual kind of transaction we want to do. For example, say creating a user. How do we create a user? So the code, the method to create a user is a business logic for user registration. So to update a user, there's a method. You can have a method to update a user, or create a student, register a student, update a user record. Those ones are what are called business functions. And those business functions, the code we write for them are what we call business logic. So business logic codes. That's what the service contains. And then we have the controller. Our controller is the endpoint, the API endpoint. What do we mean by API? API means application programming interface. Application programming interface. That's what the API endpoint is. So don't forget, we have configuration, we have repository, we have service, and we have controller. So as the simplest part, we will start from the controller and we'll start building our application back. So here, don't forget, we have configuration. Configuration means setting up parameters, set up initial parameters for app to work or start. Then the repository is code that connects to actual database. And finally, we have service. Service contains our business logic. This is how Springboot divides it. Then we have other classes, which are like AOP, template, security. We'll look at others later. Those ones are like secondary. The controller is the API endpoint. That is the one that feeds data actually to the web, to the browser, the controller. Now, before we go to coding, there's one more thing that we need to know. There's something that is called annotation. Annotation. So the concept of annotation is to bring a code that is working already into our current project without having to rebuild it. Code to bring what? To bring existing projects. Existing projects into the current project without recompiling it. It's a form of additional data that is injected into our code, which is like a metadata that tells more about a code or our class and methods and parameters or packages, to the current project. So any class that is annotated with a particular annotation, that annotation can tell us more about the class, and if it is a class that needs to be executed. For example, we have what we call Java docs. So anyone that has like at Java docs means that documentation should be generated for that very class. So we have different types of annotation. We have annotation that are informational. We have annotation that has compile time. We have annotations that are runtime processing. The informational tells more, about the class or method. That is informational. Any annotations that are informational, for example, like Java docs, tell us more about about the program, which can be used to detect error or suppress warnings. For compile time, that has to do with codes to be generated. For example, let's say we have a class called user, right? And then I put, every time you have an annotation, it starts with at. It starts with a symbol. So let's say we have a class called user. I'm trying to find the parentheses, and this is not going. Why is parentheses not going here? So let's say a class that is mapped as user, and I put annotation, say at let me put, say at let's say at getter. Now I'm saying that this class, you have a getter class, or I have say I have a variable, say string name or address, and I put at getter, at setter. Now what this is simply saying is that this is a compile time. This is a compile time annotation, which is telling the code, the compiler, that once this thing is running, it should generate getter and setter for address. So rather than us writing public void set address, public string get address, this annotation, once it's there, tools like Lombok will allow you to generate those codes automatically for you. So, and Springboot makes use of annotations to work with the classes. So, and so for those annotation is meant for runtime processing oftentimes. So each of these classes, Spring classes that I've mentioned, can be annotated. Any class that bears these annotations will automatically, take control of this. So when Springboot sees a class that is marked with an annotation controller, what it will do automatically is to write controller classes and generate appropriate servlet classes. For the one that are marked as service, what Springboot will do is to instantiate the classes by itself and then put its classes in memory so that you don't continually instantiate, thereby leading to more performance. The ones that are marked configuration is the same thing. The ones that are marked with configuration, we automatically bootstrap for configuration. That is loading the required parameters to start with. So don't forget, we have some basic annotations for Springboot that we are going to work with. We are going to have configuration at configuration. We are going to have repository at repository. We are going to have service at service. And we are going to have controller at controller. So any classes that bears any of these will automatically be transformed to whether it's a business logic code that needs to be started once, or a controller class that need to be generated as servlet for serving web pages. Right. So having done that, we can now look at our various classes. So we are going to start first with any class. Now, when you have an app, you need to map the, let's say we have class app now. This class, which is the entry point of our class. Before, what we do is to have a class with a main method, and inside the main method, we instantiate all the classes that we need and passing them as constructor to the other ones. We will do the same way, but Springboot will help us to instantiate those classes by itself and manage discovery of those classes. So at your entry point, any class that you mark as entry point should be annotated with at Springboot. Springboot application. So once Spring, so once we have such class, it will start a Springboot application, and then it will scan the whole code to look for all the codes that are marked or that are annotated with a Springboot specific annotations and do what is needful. If you get my explanation so far, type clear in the chat box. Type clear if you have gotten the explanation so far about Springboot, about Spring type of Spring frameworks that are bundled with Springboot, and various Spring Spring annotations, and you understand what annotation is, and the type of annotations that we have, and your entry class, which should be a Springboot application. If you understand up to this point, write clear, type clear, type clear, type clear, type clear, type clear, so I know that you are following. Type clear so that I know that you are following me. Type clear. Let's see where we are. Type clear if the explanation is clear so far. Type clear. I'll just do one more explanation before we move on. One more explanation. So here I talk about Springboot. Before Springboot, we talk about Java database connectivity, which is a way of connecting our service to back end. A way of connecting our service to back end. We deal with Java database connectivity, and I said that when you have especially large projects that involves, creating about 20 or more classes, having hundreds of classes, having a lot of tables, it could be very cumbersome to write all those ones and still create a web application, a web server for it. So that's why we are making use of Springboot. And I said that Springboot is a collection of frameworks, a collection of Spring frameworks that have been tested and used over time. And some of these frameworks include JPA, Spring JPA, which is Spring Java persistence, which enable us to connect to database, writing object-based data persistence to database, where we can create record, read record, update record, and delete record by using pure Java, objects, Java objects, plain old Java objects. Then we have Spring AOP, which is aspect-oriented programming, which enable us to do After Effects, which enable us to, mark different faces, or you can call it instrumentation, which enable us to, hook. That's another thing we can say, which enable us to hook another application, another function, on to a current transaction or current process that is running. If you remember in JavaScript, we talk about a callback. Spring AOP act like a kind of callback into a function or a process where a process or a method or function is called after a process is initiated, or after a process, or before a process is initiated, or after a process is completed. So we can have like a before, we can have like during, and we can have a after. An example is like sending email after a transaction is completed. Another one is like maybe sending SMS, after you have successfully done registration on a particular place. Another one is like maybe going for driver eye test, and the moment you complete the eye test, a notification is sent to the transport agency that you have been registered, and then a letter is dispatched to your house. Then we also talk about Spring Web, which contains the classes for us to to generate web server. That is, in the old days, we have web servers like JBoss. We have web server like Tomcat server. We have web server like RESTful. All these servers are enterprise servers that allows us to deploy Java applications, which are maintained on a different server themselves. However, with Spring Boot, you don't need to have a separate JBoss. It's internally bundled with a lightweight server, so that everything can run. Your code can start its own internal web server and run it. And some of this internal web server could be a Tomcat or a version of JBoss, and so on. Of course, the default web server for Spring Boot is Tomcat. You can change that to any other internally available web server. But the good thing is that this is lightweight. It means that without additional configuration, you just write your code, compile it, generate a jar file, execute the jar file, and the jar file starts a web server. Isn't that interesting? So that is good thing about Spring Web. And then we have other Spring tools like Spring templates for Jdbc, connection and data processing. We also have like Spring GMS for sending messaging. Say like emails now, we want to write email and things like that. You can actually use Spring GMS to send an email message, and so on and so forth. Having explained that, I told us that we have what we call annotation. Annotation is a way of giving a metadata information. No, I've explained that annotation is not limited to Spring frameworks. Annotation is actually a generic Java way of importing other classes or telling them specific information about a Java class or project. So it's inbuilt to Java annotation. However, different vendors can implement these annotations, just like we have a Jdbc now. Jdbc is a generic term. It's a generic framework or interface defined by the Java groups. However, vendors implementation now implement their own version of the Jdbc, which is now called library or driver. For example, we have Jdbc driver for Oracle. We have Jdbc driver for MySQL, for Postgres, and so on and so forth. Those are vendor implemented Jdbc. Now, if you look at when we are writing Java program, we could also say that this class is written by Festus. This class is written by Juliet, and so forth and so forth. How do we state that this class is written by someone? We put the annotation tag there. In the Java document, we put @author. When you put @author, anything you put after the author, an HTML document will be generated that tells us about the class name and the person who wrote the class. @author. For example, let's annotate this our class app. If we want to annotate this, we just put star, that is Java documentation. We've talked about all this before. And then I put here, I say entry class for order management solution. Now, after that, and I said that, okay, for this class, for this class, and then I have something like this. I have at author Baba-Festi. Now, so when this class is saved, and then you write, you tell the compiler to generate Java doc, it will generate an HTML. That HTML will give us the name of this class and the package it belongs to, and then we also show that the author of this document is Baba-Festi. So that is an annotation at author. This is Java docs annotation. You understand? And then let's say this class is going to throw warning. We can say, at suppress warning. We can say at suppress warning, and then we'll put the warning there. Maybe null pointer exception. Okay, so which means that if a class is going to throw null pointer exception, instead of be showing those warning, we can suppress it and put at suppress. These ones are what? Java docs annotation. Now, this kind of annotation is called informational annotation, because it just tells us information about the class. It just gives us information about the class. There's another kind of annotation which is called compile time annotation. Look at the address here. We have a private string address, and then this is a class, maybe in a user class, and I say that this address is annotated with getter and annotated with setter. Now, when you compile it, what will happen is that set address and get address will be generated. The code will be generated as part of your code, instead of you to be writing getter and setter, because you have marked this one as what? As getter and setter. However, there must be a vendor providing an implementation for this. And so, example of such vendor is a library called Lombok. So when you include a jar file, a lombok.jar file in your project, you can simply ignore setter and setter in your application. Getter and setter in your application, and much more. It can do, much more than that actually. So that is what is called what? Compile time annotation, because by the time you are compiling, it will not generate the other source code that are not part of this current source code. Now finally, we also have what we call runtime processing. This annotation tells the JVM what to do. So for example, if we mark a class as a Springboot application, this is a runtime annotation, because it will not tell the JVM that there is already a Springboot application. Go start that application and inject this class into it. Put this class inside of that one. So this class will be passed to this application. And of course, any class that is marked with a Springboot application, automatically when the program is running, it will look for all the classes that contains other Springboot application and perform what needs to be done on those classes. And I said, okay, after the annotations, then we now move to Spring specific annotations, which is we have configuration, we have repository, we have service, we have controllers. Controller generates API, RESTful API, or whether it's JSON document, XML document, video document, whatever thing that you can access on the web, that is what the controller generates. The service, what it does is that any class that is marked as service, that is annotated as service, will be instantiated once and be put in a service collections, like in a map of classes, and then put a name, so that even if you run the class 100 times, 1 million times, it will not be instantiated. It will not be instantiated more than once, and then Spring will always go back to the class pool and fetch the same class and execute whatever thing that you need from it. If another class depends on another one, Spring will just inject the one that he has created, pass it to that class for it to continue to work. If you have gotten my explanation so far, type clear. If you have gotten that so far, type clear so we can move forward. If you have gotten the explanation so far, type clear. Okay, good. So let's move on now. So that now that we have this configuration repository service controller, we are going to make use of all of them, but we are going to start from the simplest. The simplest is the controller. The simplest is the controller. For some of us that have worked with JBoss before, that have worked with Tomcat before, we will now see a magic now that we don't need to go and download Tomcat. We don't need to download JBoss and run it. We want to spin up, a server, and this server, all we just want it to do is to just generate a welcome page, a simple maybe welcome string, maybe like on our page now that we are currently seeing. We want to see the title, unlock your coding superpower. So having said that, first we have an application. We mark that application as a Springboot application. Now, there's classes that we need to import. We need Spring application and Springboot application. We need the Spring application to run a Springboot application. Now, here you see that we are not instantiating any class app. Here we have marked class app as a Springboot application, which is just enough. And then so we start this class, we start the Springboot application by saying spring application.run. Now, so once this class is running, there is a simple thing that it will do. It will look for every other annotations that are Springboot application. That is, if it discovers any class that is marked as controller, it will create, an API for that controller. So having said that, the first thing first is that we will look at our build.gradle file. In the build.gradle file, we're just going to do little updates. The first update is that we are going to have an ID to our plugin, and this plugin is Springboot org.springframework.boot version 2.7.2. You can do any version you want. But so let's start with this. So we need to have the Springboot plugin. Next is that we apply that plugin, Spring Dependency Management. So you don't need to cram it. You just need to copy this one and put it in your project. So where it gets interesting is that in our dependency, before we have only used MySQL library. Now we are going to add another library here, which is called Spring Starter Web. Spring Starter Web. You don't need to specify version from here because it will pick the version from the plugin, Springboot plugin. Now, so like I said, we have Spring Web, we have Spring Web, we have a Spring JPA, we have a Spring AOP, Spring mails and all that. So we have all those different Springboot or Spring frameworks that we can add into our Spring Springboot application. But to make a simplest Springboot application, we just need Springboot Starter Web in our dependencies. Like I said, you don't need to worry too much. You can always copy this and put it in your own Gradle file. And then in our jar file, we have this jar file, and we say this is a class for this jar file, and that's all. So the first thing we are going to do, we are going to create a class called index controller. We are going to create a class called index controller. Like I said, I'm going to just mark this one now. So let's look at it. Index controller. So we are going to create a class called index controller, and in this class you need to mark it as controller. So I have a REST controller. When we say REST controller, that means that this class is going to generate a RESTful service. And what is REST? I've explained REST to us. REST means representational state transfer. That is a service that has different states. What are these states? The state is a result of processing, HTTP processing. So you try to get a document. All right. So for REST, what are the different kind of states? We have success. We have success state. We have error. We have created. We have success. We have created. We have error. We have not found. We have BC. We have not found, and then we have moved. Now, so these are different states. So your web service documents that is serving can come in different states. That is why it is called representational states transfer. Your documents can appear in different states. When it is success, it means that the document is found or the process is completed successfully. That is success. When the state is created, it means that the record has just been created, the item has just been created, the resource has just been created on the server. For example, take a user registration. When you submit your user detail, you are registering on the website. When you submit and is successful, your record will be created at the site backend. So which means that your record is fresh and it has just been created. There's another one called error. That is that server could not process it completely. What is different between controller and REST controller? A controller is a mediator between the front end and back end. Let's consider what we call MVC. MVC means model, view, then controller. Now, so the model is the object. The model is the resource. The model is the object. The model is the resource. For example, a user data. User is the model because That is what is going to be stored. User detail that is going to be stored in database. For example, let's say social media now. You create an account with social media, or with a bank, you create an account with with a bank. You will be regarded as a customer with the bank. So a customer record needs to be created. That customer is the model. That is what every other actions will be acted on or executed. For example, account can be created for a customer, mandate can be created for a customer, transaction can be done for a customer. So the main entity there, here, the model is the customer. The view is the front end. Whatever device that or whatever channel that we use to view the model is called the view. For example, you can view your account information on your mobile phone, which means the mobile phone is the what? Is the view. You can check on console. You can check on the browser. The browser is the view. Now, having said that, between the view and the model is at the back end and the view is at the front end. What sits in between is called controller. So, and the controller could be to just get data and send it to the front end. You can generate an XML, send it to the front end. You can generate, depending on how you write your business logic, you can generate whatever thing and send to the front end. However, a RESTful controller is also a mediator between front end and back end. The difference is that a RESTful controller generates states along with the content. It generates states along with the content, and those states are what I've just explained. The state could be success. For example, you fetch data from database. The controller will respond to the front end with a success, that is, data fetch successfully. So it returns success. From the front end, you want to create an item and create submit. The controller passes it back to the backend. The backend finishes it. The RESTful controller will pass a new state along, which we say the state is now created, results created, server not found, and all those kind of things. And all these are matched to HTTP codes. So for HTTP, success is 200. Created is 201. Error means could be 500. Not found is 404. BC, I'm not too sure. I recall, but you can Google it. Find that of BC. I think moved is 301. So you just need to take a look at all this. You can Google for the details. HTTP codes for web event status. All right. Now that we have done that, we are writing. Let's just create a package called controller package in our EDU, and in the controller package, we are going to create a class called index controller. Now, this index controller, if we don't mark it, annotate it as RESTful controller, it will just be a dummy class. But now, once we mark it as RESTful controller, automatically Springboot will create endpoints for it. It will have its own path. So that is it. Now for this class, we now have methods. So I commented the second one. So let's start with the first one. What we just want you to display is that once the address is ready, once the server is ready, and we type the server address without putting path. What is a path? Now, A path is a logical directory. A path is a logical directory of a resource on the web. A path is a logical directory of what? Of a document or resource on the web. So let me take us back quickly. Let's look at a simple resource. Let's look at a simple resource. Here we have, so we are trying to define what a path is. What a path is. Look at this current page. We have https youtube.com/watch v equals to this. This is the current web address for the video that we are watching. Of course, you can type any website and see the path. Now let's break this down. If you get it up to where we are now, just write clear, please. Type clear if you are with us up to this point and you have gotten it. Type clear. Let's do that so that I don't talk. Type clear if you have gotten my explanation so far on Springboot application, on annotations, on RESTful controllers, the difference between controller, generic controller, and RESTful controller. Now that we have that, let's take a look at a simple web address. Currently, the video we are watching, let's say, is youtube.com/watch and things like that. Let's break this down. The first part of this address is HTTPS. The first part is called HTTPS, right? So this HTTPS is called protocol. It's called protocol. The protocol tells the web browser what kind of server I want to connect to. Is it a web server? Is it a file server that serves file? Is it a Git repository? You know, we're working with a Git. Is it a Git repository? Is it mobile communication network? You know, all of them, they have different, is it a messaging server? They all have different way of connecting. So the first part is what they find the type of server. So it could be HTTP or HTTPS. When it is HTTP, Hypertext Transfer Protocol, that is for web. Now when it contains S means secure website. So if you look at your browser, any site that has HTTPS, you will see a padlock. You will see something like a padlock at the address bar. That padlock means that it's a secured website. That padlock is a secured website. So, but the protocol is just HTTP or HTTPS, depending on. Then we have double slash. So everything HTTPS : / that separates the protocol. The next is what we call the server address before the next /. Before the next / is the server address. If you are watching the video, please like it currently. Currently we have a www.youtube.com. So that youtube.com is the web server. Is web server address. Web server address. Now, and this web server address is just a name that marks something. The actual machine is represented as what we call IP, Internet Protocol. So this IP is like a dotted command. For example, 127.93.this.1. This is a server address, because people cannot cram this address. That is why this IP, because people can cram it, that's why it is easier to write it in English. So this English name maps the server address. How we get it now? So we have the web server address, which is the www.youtube.com, and it could also be, something there. For example, this youtube.com now, we can get the address. If I just say, let's say ping youtube.com. If I say ping youtube.com, you will see the actual address. So here for YouTube is what? 142. .250.74.174. How many people will be cramming this every time? So it is easier to remember youtube.com than to remember 142.250.74.174. So that is why we always use the address. So like I said, a document part or a resource part is split into this. We have the protocol to access it. We have the protocol, and then followed by the address. So for the part now, you have protocol, then plus what? Plus address. After the address, then you now have the part, logical part. After that, you can have additional information plus additional details. So the additional details could be something maybe to query a specific item or search by specific name. For example, let's say we have google.com, then we have /search, then question mark Q equals to what is annotation. Now on your Google page, you type what is annotation, but what is sent to the server is this. You will have google.com, then /search, and then question mark Q equals to what is annotation. This is what is actually sent to the server. And in this context, what is the server address? google.com. Now, what is the document location? Search. So for the video we are watching, also the protocol is HTTPS, the server address is youtube.com, and the document that we are looking for is in what? Is in watch directory. That's the part. Now, in this watch now, there may be many videos there. There may be many videos in the wall. Don't forget that the part is like a virtual directory. So the watch is like a virtual directory. So we can now say that, okay, of all the videos that are in watch, I want to watch a specific one. That is why we have question mark. Question mark, when you see question mark at the end of a part or address, that question mark is called query parameter. We have what? We have query parameter. And we also have what we call part parameter. For example, a document may be presented like this. We have students, we have student http localhost / student / 1. Based on the explanation so far, HTTP is the protocol, localhost 8080 is the server address, student is the path, and then /1. 1 is the additional parameter. And this parameter, because it's not question mark, then we can say is path parameter. We call it path parameter because it is placed in the path. However, the one of question mark is what is called query parameter. So you can have additional file, maybe like /1 / test or /1 / results or courses. In this context, what I'm trying to do is that I have a student. I'm saying get a student for me, a student with ID 1, and then all the courses that the student has. This specific student. So, and then let's say I know the course now, maybe course ENG 101, say ENG 101. Then what happened? So I have students. After student, the rest are path parameter. The first path parameter is 1, followed by courses, followed by another one called 101. So 1 will map to student ID, 101 will map to courses for students. All right. So if you understand difference between path parameter and query parameter, type clear, type clear, type clear, type clear, type clear. If you get the difference between query parameter and path parameter, type clear. So like I said, we have a protocol, we have address, we have path, and this like that. So if we go back to this, if you go back to where we're coming from, and you map a class, and you annotate a class as what? As a REST controller. What will happen is that automatically, this class will generate an endpoint. Depending on how you map it, it will generate an endpoint which can be accessed on the web. So the first thing we want to achieve now is that we want this class to generate welcome bootcamp 1.0. Once we type the address, we want to see welcome bootcamp 1.0. So if you have updated your Gradle, build a Gradle file, and then you compile. So Gradle build. Let's see if we can build. Okay, so there is an error. Let's quickly fix the error. What is the error? Bootcamp. Okay, so CD, I think edu. Okay, inside edu, then Gradle build. So we build. How we can see. So we build. So it say build successful. Then after we have built, all we need to do is just to run. So we say Java, where is our file? I think is in libs, right? Libs / let's quickly look at it. I think build is in build /libs / edu, right? Okay, let's go there. Let's go there. So we have in our edu class, we have build, we have libs, and then we have edu.jar, edu dash 1.0 .jar. Let's see whether we can come up with something with this. So we run this, unable to find jar file, Java edu. Let's see, build. Let me see whether, okay, build. Just Java build slash libs slash edu dash 1.0.jar. Right. So we have this. Now, if you look at it, this starts a Springboot application. You see Springboot logo, so it starts a Springboot application. And then if you go down, you will see Tomcat started on point 8080. Tomcat started on point 8080. Tomcat started on point 8080, which means that we have started a web server which is running on port 8080. And then our main class bootcamp.edu.app is what is started. Our class is what is started. And so let's check now. So with this, we can just open up a website address and type let's go and open up our web browser now. Web browser. I'm using Chrome. Okay, so we go to Chrome and put HTTP localhost 8080, and you see that we have welcome Bootcamp 1.0, welcome Bootcamp 1.0, welcome Bootcamp 1.0. That is what will be displayed. That's what will be displayed. Welcome Bootcamp 1.0. Welcome Bootcamp 1.0, because we have not given any other part. We just put for slash, that when we have a slash, then this is just to take care of that. So when we have slash, that means that that is the root of our web server. Now let's go back. Let's update this. Let's go back to our source code. Let's go back to our source code and update this so that we can start making it more interesting. Let's go back. Let's go back to our source code and change what we already have. Let's change what we already have. So I'm going to add additional method, and in this method I want it to display when we call /watch. I want it to display YouTube. I want it to display YouTube. And then here we can see that your coding superpower. Let's see what we have here. We have say demystifying the demystifying Springboot. So let's have this and then add another annotation to this method. The first method is called index, which is just slash. We are going to add another method. Which is called watch, and we are saying that when we have slash watch, we want it to do what? To display unlocking your coding superpowers. So let's go there. We update this. We will update this, and then we will build our project again. Let's try and build our project again. Let's build our project again now. So terminate this, and then we build again, gradual build, and then after building, then we run it again. So after building, then we run our classes again. After building, we run the classes again. So now the web server has started again. So we can go back and browse /watch. Okay, so we'll go back to our web server, browser, and check what we have put there. Let's go back to our browser and just refresh. Now, if I put /watch, what do we have? We have unlocking your coding powers. Okay, let's do something interesting. Now, instead of /watch, let me put /washed. Maybe I want to see all the ones that I've washed. /washed. What did we see? We will see an error page. Because we have not gotten a controller that is mapped to /washed. We've not gotten any controller that matched to washed. So there is no washed parts. So because of that, we are getting what? Error page, and it says status 404. For example, let's say we want to search a document and the document you are looking for is not found. We can return 404. The 404 here is returned by the server by itself. That is why we're having error page that is not and the page is not neat. We can translate this 404 to make it look like, oh, sorry, looks like we can't find the document that you are looking for. Having said that, so if we go back to watch, we will get our demystifying Springboot back. Now, since we have been able to work with controller with no content, if you like, we can add more things and things like that. So let's go to our student class. We already have students that connect to database, that we have fetched from database and things like that. So what we want to do is that we want to create student controller, which means that we want to have a controller that matches to students. We want to create a controller that matches to student. We want to also have endpoint for students with ID. So if we have a controller for students, it should display all students. If we put /ID or student number, it should give us a single student. And if the student does not exist, it should give us maybe 404. Student does not exist. So let's try that. Let's go back to our code. We already have our root directory, path, and we already have path for watch. Let's try path for students. Let's try our path for students. So we go back to students. Let's go to students. So we just return to our source code. Let's go back to our source code. Now in our source code, I will stop the server again. And then I'll create another controller called student controller in the controller class. So in the student controller, we already have student service. Now in the student service, we are saying that this student controller will mark it as REST controller like before. Now this is where it gets interesting. We have a student service that we have defined. You can see that we are not instantiating any student service. We are just passing student service to this student controller. Student controller. In fact, you have gotten it so far. If you have gotten the first part of the controller we did, if you have gotten it, just type rested. Type rested in the chat box. Type rested in the chat box. If you have gotten it, the first index controller we wrote, type rested. Type rested if you get it, otherwise type restless. Okay, good. So let's move on. Let's have a controller for students. And how do we have controller for students? Just write a class, call it student controller. It's as simple as that. And that student controller, annotate it. You already know what annotation is. Just put the @ character and then with the annotation name. In this context is REST controller. So we have @REST controller for student controller. This student controller needs student service to fetch student data. Now we have various methods. We have get students. And this student, we want to mark it to the part students part. Mark it to students part. The next one is we want to also find student by ID. Don't forget, these are the parts we want. We want something like this. We want students. We want /students. And then we want something like /students /say 3, where students is the first part and 3 is the student's ID. 3 is the student ID. So when the ID is not supplied, we want it to fetch all the students. So that is why we have the request mapping here saying students. And then, of course, this will return a list of students. Now, one good thing about this is that because this is a RESTful controllers, automatically Springboot will convert the students data, students list, array list, to convert it to a JSON data, like a JavaScript, JSON data, which is passable and readable by the front end. So when the ID is not supplied, we want to return all students. So we have student service.find all. When the ID is supplied, we want to find a single student. Now, so how do we find a single student? you can see slash student, and then we have ID. We have ID in call brace. What this is saying is that we will have a path parameter called ID, which the controller will substitute once the controller sees a path. Once a controller sees a path that starts after student, it will split it. It will take the student as the path, and will take the next one as the ID, because in the definition of the declaration of the endpoint for students by ID, we have the ID in the path. Now, instead of this, if we had done something like this, there is another way. There is another way we could have students. We can have students /1, and then we could have students $ID equals to 1. Now, if we map something to student ID equals to 1, it means that since we have question mark here, ID will become a query parameter. If we have slash instead of question mark, then ID will become what we call path parameter or path variable. Right. So for this one, a well-structured RESTful service uses the path parameter, the path variable, the path variable, the path variable. So if we do that now, we are trying to look at the CRUD, that is create, read, update, delete. So what we have now, get all students is a get request. Is a get request. So the method is guest. For creating a new record is called post. So we will have a post mapping. Now, if we are going to update, you use, I think I've explained that before. You have this. We have a HTTP verbs. Let's go back to what I'm using to do documentation. We have a HTTP verbs. HTTP verbs are the actions that you take on HTTP, which corresponds to different states. So we have the get, we have the post, we have put, we have delete, we have head. Right. So the get is more like, is translated to selecting record. It does not modify the record. So, and that is, we call it is idempotent. Idempotent, that is whatever action that will not modify a resource, that will not change the value of the result, no matter the number of times you call it, it is idempotent. So if they ask you in your interview, what is an idempotent API or endpoint, it means that an endpoint which does not modify a resource. An endpoint which does not modify a resource, no matter the number of times that you call it, is called idempotent. Idempotent. You can Google it. Or what if they ask you what is idempotency? That's another way of just question can be twisted in any way. All right. So we have the get. Get is to fetch record. The post is to create record. So like on your form, you fill a form on the web, and then you click submit button. That submit button will send what we call a post request to the backend. When you call a web page, that sends a GET request to the backend, and backend always return with 200 if the document exists with the document. The put request also updates. Maybe you want to update some part of the existing record. Update the record with the ID of the record. Delete sends a delete request to delete the contents. And then we have head. The head is to return the information about the document without the actual document. For example, if I send a request called head with a student and student ID, it can just tell me that success and then says that a student exists, but it will not send me the record, the actual student data. That is what head is used for. So having said that, in our mappings, so we'll have request mapping. This request mapping, another way we can just say get mapping. We can just say get mapping. We can just say get mapping. And this request mapping, you can also put it on top of your class. If you put, like, say, this in front of the class, on top of the class like this, you put request mapping, then it means that the whole class is mapped to students. Then every other places where you have a mapping, you don't need to now put anything again. For example, under get students, I can now comment this out or remove it totally. Under request mapping for this, I'll just say get. Here, I'll just call it get mapping. And what would this one do? This get mapping, I will just remove the students. Because the base class is already annotated with what? With request mapping students. The base class is annotated with students. The post mapping, I don't need to put anything there again. You understand? I'll just say post mapping. For this one, for get all students, I'll just put what? I'll just put get mapping. At get mapping. At get mapping. What else? Then we have at put mapping. Here, because the base class is mapped to students, I don't need to put students in the part again. You can see that we now have a class which is mapped to what? Request mapping is to students as the base class. So you can create another one as an assignment. You can create department now. You create department controller and you map the base class as what? Request mapping / departments. With that, when you call get all, it means that you just get the same thing we did here under what is it called now? Under index controller. We can take this get mapping from here. We can take this request mapping and take it to the top of the class. Once we do that, we'll change this one to get mapping without any slash. Automatically it will fetch that. And then here we can just say get mapping / watch. All right, so back to our student controller. So we have student controller which is mapped, which has annotation of request mapping / students. And then to get our student, we just put get mapping. To get a student with ID, we put /ID. The ID will be in call brace. And then create student also, because it's going to send it to the base part, which is /students. So we don't need to put the URL. For put mapping requires a specific student, which is the ID of the student. So we need to send it there too. Don't forget, this is a part variable. So in our method, we need to define that this is a part variable. For the student, we need to annotate it that this student object is what? Is the form data that we are sending. The form data that we are sending from front end. Now, so what happens to this is that whatever thing that is sent from front end, because this is annotated as request body, Springboot will convert the data to student objects, which we can access. You can see the beauty. So, and once it is created, we can return a response, okay, or response created with a particular resource. And then we can return students, okay. For this one, we are returning the objects. So, and that is it. You can see one more time. Let's go through it. Declare a class and annotate it with REST controller, and then the request mapping, which should be the base class for every other data within that part. Then when you need to get a single item, then you put /id. When you need to update a single item, you put /id. Otherwise, there is no need to put any parts again. You can see that's the controller, but this controller requires student service. That means we need to have a class called student service and mark that student service. We are going to mark that student service as so let's come. So we have a service, and I call it student service. So we have student service. So in this student service, this is it. We have student service. Service. What does this do? Is that if you annotate this one as at service, say at service, when Springboot is running, Springboot will discover it. So, but what I want us to do is that I'm going to leave that service for now. Let's conclude our controller parts. Let's build the student controller. This is the student controller. Where is the student controller? Require the student service, and the student service is this. And student service requires the student DB. Requires a DB. So DB will put DB in configuration, which means that that's what needs to be started first. Once that DB is started, it will pass to this. So I'm going to start like this. Let's say when this class is instantiated, let's say DB equals to new DB. And we annotate this as a service. The student controller will go fetch student service. Now, after fetching student service, then it will pass the student service to his own constructor, and then use student service. So let's build our project again. Let's build our project again. So after building the project, Let's try and run. Let's see whether it is going to run. Okay, so it says server started. Let's try and check our let's go back to the browser. We are rounding up. Let's go back to our browser and test again. So go back to the base class, and then let's start the student class /students. You can see it produces JSON data of all the students in the database. It produces a JSON data of all students in the database. Now let's pick a particular student. There is ID 1, there is ID 2, there is ID 3. Okay, let me just pick ID 3. I expect it to give me Jake Cake. So let's say ID 3/3 and press enter. You can see that it also gave us this. For post and put, we can try something to do that. Post and put, we just need to have let's try and see. Since we don't have a form now, when we go to front end, we can do that, but we can try something. We can try something which is called a CU. It's called call. It's called CURL. Let's see how we can handle that. So I'm gonna go to what is it called now? Let's go to the terminal. Terminal. Let's see terminal. Let's see whether we can undo post. Otherwise, we will end from here. Terminal. So terminal. Let's try the terminal. There's something called CURL, and the CURL will just take like header of information and things like that. This might be too much for us, but I'd like us to try it. Let me write the code here. Let's say we'll create form for it. This is where we are going to end for today. Let's quickly see if we can post record. Let's go back to our code and type the terminal code. Let's see the terminal code. Here we just have say CURL. Let's say I have CURL. I hope I'm displaying the terminal. Okay, good. So we have CURL. Let's say our header is content type. This may not make too much meaning for us. Application say /JC. That's the header. Application /JC. And then we have say request, and say is post. That is our method is post. Our method is post, and then what are we posting? We'll say data, and I'm going to put the other one that I'll copy here. So this is the data, no ID. Here name is Dino Jamil. Okay, let's have Dino Jamil, and the street is Venture Estate. And the city is in which city now? Let's use Lagos. States, Lagos, LA. Okay, so that is and then what is our site? HTTP localhost 8080/students. Let's see whether we can work with this. So I'll go to the terminal. I just want to put the code on the terminal. Let's put the code on the terminal. Don't worry, we can, if we don't get this one, when we do web, the same thing, the same form you submit on the browser, you can also submit on your command line by using the CURL. And then so we put, we got the student record created as response. That's good. But is it true? Is it true that student record was created? So it means that we should have like 4 items now. If we go back, let's go back and check. Let's go back and check to be sure that what we did is actually done. So I'm going to go back to students part and refresh. Students, yeah, it's created. So we have 4 items now. I can see Dino Jamil. In fact, if you do like this, let's inspect. Maybe inspect will even be better to look at it. And then look at console. Okay, it's not written to the console, it's on the page. Okay, because it's not a JavaScript. Okay, so we have it. And I think the code, the ID 6409, ID 6409. So this student now /6409, we expect it to give us only Jamil data. Yeah, we got it. So ID 6409, name Dino Jamil, address. So we just sent a post to the server, and then this was created. In our next class, we focus on front end, and now we can use front end to connect to the back end. Yeah, this is our front end in a way, but this is server generated front end. We want to see the one that JavaScript. This is going to connect to this. Let's see how we can use JavaScript to connect to the back end to fetch the same information so that we can render it correctly. You know, here is the JSON. It's looking like it's not human readable, as it's not that friendly, but we can display it in a table. You know, like we had before, we can display the student data in the table. We can display specific student detail on click of a button. So in our next class, that's what we'll be looking at. We'll be focusing on, you know, what we call single page application. We'll be focusing on connecting to the back end and fetching data and displaying it. That will help us to complete the full stack that we really want. If you get explanation tonight, I think you should type rested again, or type complete. Let's use complete as a different. Let's use completed. If you get the explanation so far, type completed in the box. Somebody is writing, Professor. Is that what I asked you to type? Type completed if you have gotten it. We have demystified the Springboot. You know how Springboot works now. You don't need the big JBoss application. You don't need big Tomcat. So you have started a server. You are communicating with your server backend. You can create. You can read from that server layer. Backend. We can actually do updates too. If we want to do updates, you just change that request from post to put, and then put the address ID, because ID of Dino was not in the data we sent. So we can also do that. So I think we are going to drop the curtain from here. Let's see whether we can have opportunity to do another class tomorrow, where we'll be looking at front end proper. We will review our JavaScript fundamentals, our objects, our list, our map, our loop, how to loop through JavaScript objects, perform some filters. After that, then we connect back to the backend and fetch data from backend. If we're able to do that, then we are fully ready to start taking up jobs. So thank you for staying to this moment. If there's any question, type your questions. We have spent almost 2 hours, so type your question. We have 3 minutes, and I feel like using the rest 3 minutes to do an update. Let's do an update that will be calling a put method. So let's see our terminal again. Let's switch to terminal. Let's switch to terminal. Where is the terminal? So let's see if we can make use of this few minutes that remain. So here, the first thing I want to do is that let's add more records. So we have Jamil. Let's add this city of Lagos. That is then in the estate. Let's have Bayero Paul. Let's have Alhaji Michael. Let's have Chinwe. Let's have Chinwe Bello. Okay, so we have more records created now. So if we simply do CURL and we just say CURL and call students from our console. you can just type the path in the server. Let's see, curl. So this display all the records that we have, and in this record we have 6610 by Paul. We have 8441 Alaji Michael. We have 9508. Okay, so let's say let's check the last entry here, 9508. That is Chinwe 9508. Okay, that gives us Chinwe. That gives us Chinwe. Now let's modify Chinwe's record. Instead of Chinwe Bello, let's call it Chinwe Osaje Bello. Chinwe Osaji Bello. And Chinwe is 9508. So we are going to change the name to Selenke Bello. Chinwe Selenke Bello. And we are going to add an ID. Say ID. And this ID is, what is the ID? 9508, right? 9508. 9508. And the method will be put. Let's see whether our put method actually works. Okay, error. Method not allowed. Error, method not allowed. Error, method not allowed. So what that simply means is that we don't have a put method correctly, mapped. We don't have our put method correctly mapped. So we can look at that later on. Okay, I see. It's correct. In the put method we have, you can see we only have path variable, and it doesn't have a request body. We are supposed to have a request body, so it should have a student body. So we can implement this in our next class. So thank you so much. We'll drop it. See you in the next class. Bye.